right, 3.5 is savings and annuities. So there's actually 3 different places in your spreadsheet that you will do calculations for this section. And getting used to which one does which is probably the hardest part of 3.5. But I'll give you some tips and tricks on how to do that. So part of smart financing is finding low interest on rates on loans, but the other side is getting a high interest on investments. And the simplest form of saving money and collecting interest is in a savings account, which you may have along with your checking account. Interest rates for savings accounts vary, but are around 1 to 5%. As college students, you may just be trying to get by, but at some point you'll start thinking about saving for retirement, and that's where annuities come from. The better known ones are 401k and IRA plans, which you might have heard of. So the first thing we're going to talk about is a savings annuity. This is what you use when you have a savings goal and you're putting regular deposits of equal amount. All right, so you can see that it's a pretty complicated formula, but I think the only thing different or new is the K. We didn't have a K before. So K is just your number of compounding periods. We're using that instead of lowercase n. And then notice that uppercase N is years. D is the regular deposits. We haven't had that before. But R is interest rate like it's always been. So the lettering is a little bit different here. Most of the time you can use your spreadsheet to solve these, but if you're trying to find, we'll see an example later on of problems where you wouldn't be able to use the spreadsheet for these. So important things to note about annuities are that in an annuity, the deposits are made regularly and on the same schedule. The amount deposited is always the same. So regular, always the same. And then annuities have many deposits, whereas compound interest investments only have one deposit. So here's an example one is actually a homework problem. Which of the following best describes an annuity? Check the correct box. So the first one is a lump sum is deposited into an account earning simple interest. No, because that's only one deposit. Deposits are made at random. No, because for an annuity, deposits have to be regular. Equal regular deposits are made into an account. Yes, that one. That is what an annuity is. All right, let's do an example where we find some information. We're doing a savings annuity here. We're depositing $1,000 each year into an account that earning 4% interest compounded annually. How much will you have in the account in 35 years? So we'll highlight the pertinent information. $1,000, 4%, 35 years, and it's compounded annually. And we want to know how much you'll have in the account. So that's the same as finding the future value. So you're going to have 2 savings annuities in your a spreadsheet. We're going to have one where the future value is known and one where the future value is unknown. So in here, since we don't know the future value, we're going to use the savings account with future value unknown. And it's usually pretty obvious because if you look at the 2 and compare what information you have with what information you don't have, you'll see that only one makes sense to use. So if we put the $1,000 in for the payment, so you don't put anything in present value because we're assuming that you're starting from 0. And then 4% interest, compounding period is 1 because it's annually. We're doing this for 35 years. And we want to know future value. So that's this value right here. It's the $73,652.22. So in 35 years, I will have $73,652.22. All right, example B. Suppose you want to have 600,000. So notice right away that this one's different. Now we know the future value. So we want to use the future value known portion of the spreadsheet. And we're doing this in 20 years. Your account earns 7% interest. How much did you invest each quarter? And how much total will you put into the account? All right, so we'll put the information in. $600,000, 7% interest. This is for 20 years, and it's, I have a mistake on this. It's compounded each quarter, so that should be actually just 4 times a year. Let me try to fix that. All right, so that's going to change some things up. Let me see if I can open this up in Excel. I don't know. Do I have anything in here? Book. Okay, well, maybe I can do it in Sheets. Okay, so you want to be on this tab here. If you're in Sheets or Excel, it doesn't matter. It's going to look basically the same. So we're doing the one where future value is known. So in here, I'm going to type 600. Oh, I guess we got to delete everything. Return, and then this should be 7%. It's for 20 years, and then it's compounded 4 times a year. So that changes things a little bit. Let me make sure. Changes things a lot, actually. If we go between, I'll show you guys what, undo. If you get stuck in something, just like click into another cell. So I want to be here, and it doesn't automatically type over like it does on a regular computer. So if I put compounding periods are 12, it's like 1100 something. But if I change that to only 4 compounding periods, it becomes a lot more. So I'm just going to write these values down. And then they wanted to know how much you're putting in total, which is the 279,404.69 value. Okay. Actually, not a bad mistake to have, because then I got to show you guys how you would actually do it. So none of these values were correct. So the correct payment is 3492.56, and then this one is $279,404.69. And I didn't write down the interest earned, but it doesn't ask us that, so it's okay. So I want to know how much total do you put in the account and how much do you invest each quarter. So those values are the ones that I just wrote down, so I'll circle them. Those are both the answers. All right, so the first two examples we did, those were about savings annuities. So what about once you've already retired and you have all this money saved up, then you're going to use a payout annuity. So a payout annuity tells you, based on how much you're starting with and how many years, compounding periods, and interest rate that you have, how much you'll be able to take out for each period. So most people take their retirement out on a monthly basis, but you don't have to. Okay, so it says that you have $400,000 saved for retirement and your account earns 5% interest. How much will you be able to pull out each month if you want to be able to take withdrawals for 15 years? So highlight the important information and each month, so it's 12 times a year, and then we're popping it into the payout annuity. So this one's kind of more straightforward because it's the only one that pertains to getting money out once it's saved up. And it wants to know how much you'll be able to pull out each month. So that's going to be the payment. So I will be able to take out $3,163.17 each month for 15 years. And the rest of the money is going to sit in that account and keep earning interest. Okay, we have one last example. This is one where we have to do it by hand. So you want to be able to withdraw $25,000 each year for 25 years. So we'll highlight that. And we get 7% interest. How much do you need in the account at the beginning? How much total money do you pull out of the account, and how much money is interest? Okay, so this is the savings annuity formula. No, it's not, sorry. We're pulling money out each year. So this is the, let me go back to it, the payout annuity formula. So we're using this guy. Right? Hopefully that makes sense because it says you want to be able to withdraw. The other two deal with putting money in, not taking money out. So we'll start by writing down the formula. So that's all over R over K. And plug in what we do know. We know that we want to take out $25,000 each year for 25 years. And then there's a 7% interest rate, and it's annually, so divided by 1. And then that gets raised to the negative 25 times 1, all over the 0.07 over 1. Now, since it's over 1 in all those places, you don't actually need to write it, but I was going to show you, oh yeah, we should have an extra parenthesis right there. I was going to show you how to do this in Desmos so that you can, if you have other problems that are using this formula, you can just change the numbers up and keep using the same formula. So let me see if I can find Desmos on here. Obviously not prepared. Google. Here it is. There's just so many apps. Yeah, so this is the graphing calculator. Let me see if I can change it. It doesn't matter. Graphing is fine, but yeah, I don't see how I can change it. Oh well, that's fine. So up in here, I'm gonna type what we have. Now I'm gonna, even though I didn't write the parentheses, opening parentheses on paper, I'm gonna put them in here because I need to let Desmos know that I'm gonna be dividing by more than just one number. And then pretty much just typing it in exactly how it is on your paper. So 1 minus parentheses 1 plus, and then 0.07 divided by 1. And I'm putting the 1 in there just because if I go to use this Desmos again to do another calculation, then I can just change that 1, update it to 4 or 12 or whatever it happens to be. And then my exponent is negative 25 times 1. And see how it moved the 1 down when I don't want that? So I'm going to go back up here and do a parentheses 1. And that way it stayed in the exponent. And then we can close that parenthesis and the other one, and then hit divide, 0.07 divided by 1 again. So it is saying that the answer is $291,339.58. So I would just jot that down somewhere. And you can also, well, I don't know if you can on the iPad. Let me see if I can copy. No, it's a little bit awkward. For the other two questions, I actually could use the spreadsheet. Because now that I know how much I need, I can figure out, well, we can test it out in Excel or Google Sheets, the spreadsheet, make sure it's correct. So 291, sorry, you don't actually put the comma in there. Maybe you can, but I'm not going to because I don't want to mess it up. Okay, and then we get 7% interest for 25 years. That's right, but it's only compounded once. And it matches up with the original problem saying 25,000 is what we want to be able to get paid each time. Future value, yeah. So then we can check it in total paid out, total interest earned. See, the other questions were how much money will you pull out of the account? So that is the, oops, let me just click off. No, stop. It's a little awkward on, hopefully I didn't mess this up. Yeah, I definitely messed something up. Well, you can always just hit undo until you're back. Oh my gosh, I get into trouble when I'm on this thing. Okay, so let me do edit again. It was just there too. All right, my undo button isn't working. Well, this is an iPad. I don't recommend doing this stuff on an iPad. All right, well, I have it written down anyway. The answers were given in there. So the purpose of putting it in the spreadsheet is that you can check and make sure your answer is right and get the other two answers. So we get that P sub 0 is $291,339.58. And the total paid out is $625,000. You can also find that by just multiplying the 25,000 by 25 years by 1 time a year. And then C is how much interest is earned. So you can get that from the spreadsheet, but you can also just subtract the two values, how much you got in total and how much you actually had to put in. The rest would be interest, and that's $333,660.42. So just circling all my answers here. Hopefully I didn't confuse you. So just to recap, this one you can't use the spreadsheet for because the thing you're trying to change is one of your formulas. So I'll just go back to it as again. And then I'm going to have to fix it when I get off this iPad. But anyway, the thing that we were trying to find is a formula. You see when I click in it, you get all this formula stuff. And if you ever get stuck in the formula, you can just hit escape or check on the iPad works. So we can't put $25,000 in there and hope that the present value will update because that's just getting rid of our formula. So we had to do it by hand, and to help us with that we use Desmos just because a regular scientific calculator is fine, or graphing calculator, but you see that when you use Desmos, let me see if I can make this bigger, you can see, oh yeah, that's better. You can see the whole thing in one really nicely typed up calculation. Okay, and then I plugged it into the spreadsheet just to check it and make sure it came out. And then we did a couple calculations either by hand, or you can get them from the spreadsheet to get the total interest or the interest earned and the total amount that gets pulled out of the account. All right, finally done.